we ended with the domain yesterday, and I gave you that handout that I'm sure you have all started on and been working diligently on. We are going to cover the next little piece today, talking about compositions, and then tomorrow we will do the word problems, and then all of that handout then would be due on Tuesday, if we don't have school Monday. So, 3-day weekend, we all need that. Always. Okay, what is a composition? If I say F composed with G, what does that mean?
Just put it in I don't know
Don't you just
like you put it in both of them. I don't know.
Yeah. You're doing both functions, so F composed with G. You might also see it written with parentheses F of G of X. Do you start on the inside or the outside? Inside. So I have to start with that G of X, which is X minus 3. And then I plug that into F. So F is whatever you plug in squared, so that would be X minus 3 squared. So is that X squared minus 9?
Yeah.
A negative would be a positive. Or, oh yeah.
Yeah. So X minus 3 times X minus 3, so you get X squared minus 6X plus 9. Alright. So is the other direction the same? No, you have to flip them. So G composed with F means I'm starting on the inside, so I'm going to take F and I'm plugging that into G. So I'm doing G of X squared. So if I plug that in, we get X squared minus 3. So order matters when we're looking at compositions. Alright. So far, so good? Look at this. Doesn't it look beautiful? So, I'm asking you to do these compositions. But instead of giving you functions, I give you a table of values. So f of g of 1 means I start with g of 1. If x is 1, what is g? 6. My x is 1, my g value is 6. So now I have f of 6. So when x is 6, f is 5. So our a is 5. B, g of f of 1. So when my x is 1, f is 3. And when x is 3, g is 2. You guys all see where I'm getting these? F of 1, so starting on the inside, f of 1, so when x is 1, f is 3, so then we have f of 3, when x is 3, f is 4. You guys try the last 3. So D, g of 1 is 6, and g of 6 is 3. Did you guys get that? E, we start with f of 3. So when x is 3, f is 4. Then g of 4 would be 1. And f of g of 6. So when x is 6, g is 3. So then we have f of 3, which is 4. We good with those? We are going to take a short break from our notes. I want you guys to find a partner, and on Classroom I posted a handout that I want you to work through with your partner. So you can do it on your notes. So we've done it from a table and from a graph. Let's do a few more with looking from equations. So G composed with F, and here are the functions. So G composed with F. We have G of F would be a 3x minus 1. Plug that into G, so we get negative 2 times 3x minus 1 squared minus 4 times 3x minus 1 plus 5. Okay, now I need to multiply all this out. When I have 3x minus 1 squared, what do we have to do? FOIL. So 3x times 3x would be 9x squared. Negative 3x and negative 3x would be negative 6x. Negative 1 times negative 1 is positive 1. Minus 12x plus 4 plus 5. Distribute my 2. Sorry, my negative 2. And add our like terms. So we get a negative 18x squared. Positive 12x and negative 2x cancels. Negative 2 plus 4 plus 5 is 7. Okay. So we're doing F composed with G. So we have to do F of square root of x plus 6. So that means we have the square root of x plus 6 squared plus 4. A square root and a square, what happens? So we have x plus 6 plus 4, or x plus 10. So far, so good? We have just a few left. Why don't you guys try the next slide? So I gave you some equations and asked you to do a couple more compositions. So try those on your own. F, and then I have f of the square root of x. So if I put that in, I get the square root of the square root of x. You can leave it like that. What is a square root of a square root?
Is that a cube?
You multiply those, so it's a fourth root. So either one of those, whoop, fourth root of x. Either one of those would be okay. All right, G composed with F, so G of the square root of x. So if I plug that in, I get the square root of 2 minus the square root of x, and that's all you could do there. Okay, now I had you go ahead and compose them. Now I want to talk about the domains. When we do the domains of these things, you have to look 2 places. You have to look at the original inside and the final answer, and I have to put those things together. So on this one, if I have the square root of x, what do you know about x? If I have the fourth root of x, what do you know about x? Even roots are always greater than or equal to 0. So when I put those together, that's pretty simple because they're both the same. It's just going to be 0 to infinity. Okay, G. We have to look at both of these. So this one, that's just the greater than or equal to 0. Okay, here, whatever's under the radical has to be greater than or equal to 0. Okay. over my square root, it tells me the square root of x has to be less than or equal to 2. So x has to be less than or equal to what? 4. So it has to be bigger than 0, but smaller than 4. So this
Wait, how did you get
squaring. So this says starts at 0 and ends at 4. It's only the numbers in between those. I'm going to do one where we compose 3 functions. So I want f composed with g composed with h. You did this with the graphing example. U again, this just means f of g of h of x. So we start on the inside. What is h of x? So now I have to plug that into g. So g is whatever you put into the 10th power. So it's x plus 3 to the 10th. Then I have to put that into f. So f is whatever we put in over whatever we put in plus 1. Is that one okay? Alright. Last example. I want to go backwards. I'm telling you the answer to the composition. I want you to tell me what the original functions were. Okay, so in other words, I'm saying that f composed with g, when I worked that out, I got this for my answer. So g is the inside. That's the thing you do first. If you're going to plug a number in for x, what are you going to do first? A couple different ways to think about it. The inside is where you start. If I put in something over here for my x, if I put in a 2, what are you going to do first? If I told you to work it out. It's really not a trick question, guys. If I put in a 2, what are you going to do first? Multiply by 3. Okay, so a couple different answers. G is the inside, so if you think about, you can think of it as the inside or what we do first. You can define your g of x to be that. So I'm going to say my g of x is 3x. Now when you plug it in, you replace x, right? So if I take that back out, if I take my 3x out, it goes back to being just a plain x. So that means my g is 4 over x minus 4. Sorry, my f is 4 over x minus 4. There's not always just one right answer. Another one, if I had said my g of x is 3x minus 4, then what would f of x have been? So a lot of times there's more than one possible answer. You just have to give me one equivalent option. All right, let's try some more of those. That was a struggle. So B, f composed with g, so that means your f of g of x equals -2 times the absolute value of 7 minus 3x. Alright, I want to know what g of x could be. G is the inside. Somebody give me one option for my g of x. 7 minus 3x would work. If you do that, what would your f of x have to be? -2
Or x.
absolute value of x. You could define your g of x to be the absolute value of 7 minus 3x. And then f would be -2x. Whatever your g is, take that out and just replace it with an x. And last one. F of x is cosine squared of x plus 9. And I want 3 functions. So f of g of h is equal to cosine squared of x plus 9. Bless you. We'll start on the inside, bless you, and work our way out. H of x is the first thing. What would you do first if you plugged in a number for x? Add 9. So let's say h of x is x plus 9. Okay, so if I replace that, then it's a cosine squared x. So g, if I'm working my way out, what's the next thing you would do? You would, if you cosine squared, remember it just means the cosine of x, and then square that answer. So the next thing you would do is the cosine of x. If I replace that with just an x, I'm left with x squared for my f of x. Okay, so it's just working backwards, taking those things back apart. That is where I'm stopping for today, so that leaves us 4 word problems we will look at tomorrow. You've got a little bit of time if you want to work on that packet. That is due on